We have Boyan jumping in to talk about his NUMA work. So I just want to take up a couple of minutes of your time, since, as Michael pointed out today, bhyve recently gained support for emulating NUMA inside virtual machines. So I would just like to kind of, first and foremost point you that this option exists. You can use it, and kind of lay out a couple of use cases that might be of interest. So this originated from my virtual memory work, where if you're implementing anything if you're basically adding any new mechanisms, patching things, you have to make sure that the thing you're developing works on NUMA machines. So, and if it doesn't, that usually means that you have oftentimes run into a lockup when dealing with memory shortages and stuff like that. So these patches have been in the tree for a couple of months now. They've been in review for several months, but yeah, that's to be expected. And yeah, so for first and foremost, I think the most common use case is going to be, okay, I need to test something NUMA related. I don't have a NUMA machine. Those are expensive. So you pop this. And so the way this option was envisioned, it allows you to specify, oh, oh, which is the, it's visible. So it's the dash run option. So the way this works is you can associate a given set of CPUs with a specific emulated domain, and you can give it an arbitrary memory size. Of course, as much as your hardware permits anyway. And you can mix and match, have as a maximum of 8 NUMA domains. And the other use case, the full thing is that you can also control the way that a specific emulated domain's memory is allocated. So for instance, let's say that you have an actual NUMA machine on the host, and you want to pin a certain virtual machine to a certain host domain. You currently can do that, but only for the CPUs, right? Memory is being allocated in an interleave fashion, which means that it's kind of spread out across all domains in the host. This way, you can actually tell it to source memory for that specific VM only from a domain that you want to. So from a local domain, from all domains, you can control practically the way memory is allocated for that given VM. So skipping ahead, I think there's a couple of examples right at the very end. Yeah. Okay, so here are a couple of incantations. The first one being just a very simple rough use case of I want 2 NUMA domains with 4 gigabytes each. Nothing too, exotic, I hope. You can assign any combination of CPUs you'd like to those machines. And an important caveat here, it only supports running in UEFI mode. So bhyve load, the usually the one that's now considered to be deprecated, it kind of preloads and pre-creates the bhyve loader, pre-creates all the memory configurations and the memory the slices for the virtual machine, and editing those after they've been created is just too complicated. So yeah, sorry. And the other thing, the second use case I was talking about. So this size here basically says that give me a virtual machine with a single emulated NUMA domain, but I want to only allocate only want to allocate memory from from domain number 0 on the host, which if you're using any sort of, I guess, high impact traffic, you want to minimize the bandwidth. You want to minimize bandwidth traffic across NUMA domains, right? So this way you can effectively pin this virtual machine to domain 0 on the host. So you avoid this cross domain traffic. And that's about it. I mean, I hope that somebody will find this useful. Mostly for developer vocals right now, but yeah, that's it. Any questions? Great.
Thank you. Awesome.